I had some questions from people about part C of number four, so I want to take a look at that. It's people getting in line at an amusement park, and they want us to figure out at what time the line for the ride is the longest. So, first of all, think about the fact you have a function here, maybe you could call it function L, that represents the number of people in the line at any given point in time. And so, if you think about a function, normally when I'm working with the function, the maximum value for that function or the minimum value for that function is going to occur either at the endpoints, bad drawing here, but either at the endpoints or at the relative minimum and maximum points. And those relative minimum and maximum points, uh, those are the places where the derivative is equal to zero. So that's really what we're looking for here. We're looking for places where the derivative function is equal to zero, okay, where the rate of change is zero. Well, okay, so in this particular problem, what's affecting the rate of change? There are really two things here affecting the rate of change. There's the rate at which people come in, okay, and there's the rate at which people are getting on the ride, okay? So you have people coming into the line and people getting onto the ride, okay? And that's going to explain the overall rate of change. So I'm going to write this is L prime. That's the rate of change of people getting in line, basically, and L is representing the total number of people in the line. So the rate at which people are getting in to the line is R of t, okay? It's just that function there that they gave us. Now it's a weird function because it is you know, you got to look at the diagram there, but that's a rate. And people are getting onto the ride at 800 per hour. Okay, so if you think about it, let's just look at the scenario. So if you look over here at the start of the day, 1,000 people are coming in every hour, and 800 are getting onto the ride every hour. So what's happening is 1,000 come in, 800 get on the ride. That means you have 200 extra people left over. Okay, which means that the line is going to be getting longer and longer and longer. If you think about that a little bit more, then the point at which everything kind of levels out is when the rate at which people are getting into the line is the same as the rate at which people are getting onto the ride. Okay. And remember, the relative maximum or minimum happens when the derivative is equal to zero. So that makes sense, right? If this is 800 and that's 800, that would give us a derivative of zero, a rate of change of zero. Okay. Well, so where is that moment where people are getting onto the ride at the same rate that they're getting off? It's at hour three. Okay. At hour three, we have 800 people getting on. And if you notice, after that, we have fewer than 800 people getting on every hour. And so after that, the line is increasing more slowly than the rate at which people are getting onto the ride. And so the length of the line will be decreasing at that point. The follow up to the question was, what's the total number of people in the line at that point? Well, the total number of people in line at that point would end up being, well, there are three things we have to consider. Initial values are always really important. There were 700 people in line at the start of the day. Okay, remember that you can take the integral of a rate over a time period to tell you how much change took place because of that rate over the time period. So I can take the integral of my rate function here. That's going to be the integral from time 0 to time 3 of my r of t function minus 800. Okay, technically dt. Okay, now the integral of r of t, we just have that graph. Okay, the integral of r of t is the area under this curve in that first 3-hour period. Okay, so you're going to need to find the area under that curve, and that's going to tell you how many people, because you're finding the integral of a rate, it'll tell you how many people came in the line in that time period. Okay, the integral of 800 is 800t. Okay, so you'll find the area here. You'll have 800t here when you take the integral of 800. And when you substitute in 3, of course, for this, you're going to get 3 times 800. It just means 24 people got onto the line in that time period. So let's go take a look at their solutions here and see how they put all this together. So if you notice here, um, notice the line as long as t equals 3, we said that. You have 700 people at the start. 3,200, that's the area under that curve, the integral between 0 and 3, which is how many people got in line over the course of 3 hours. And then 800 times 3, 800 people get onto the ride every hour, and it's happening over 3 hours. So 3 times